For this homework question, you can calculate the electric force using Coulomb's law. It says that the electric force is Coulomb's constant K times the magnitude of the charge on an electron times the magnitude of the charge on a proton divided by the distance between them squared. That's going to give you the magnitude of the force, and then you should know the direction of the force by remembering that the electron is negative and the proton is positive. To calculate the gravitation force, you'll use Newton's law of gravitation, which is Newton's constant G times the mass of the electron times the mass of the proton divided by the distance between them squared. We remember here that the gravitation force is always positive. You can work through this, and I will post the answers. In this homework example, we have two charges. Q1 is placed at x equals 0.15 meters right here. Q1, that's a positive charge. And Q2 is placed at x equals minus 0.15 meters. So this is the x-axis, this is the y-axis. There's Q1 and Q2. We're asked to find the x and y components and the magnitude and direction of the electric field at two places. So the first place we want to find the electric field is if x is equal to 0.3. So right here, there's point A. And then we also want to find the electric field if x is equal to 0.15 and y is equal to -4. So down here somewhere, minus 0.40, point B. Okay, to get started on this, what you have to do is draw the electric field vectors due to each charge. Q1, and let's deal with point A first. Q1 is a positive charge. We know the electric field points away. So at point A, the electric field due to Q1 is going to point away. It's going to point to the right. So there's the electric field due to 1 at point A. Got to do the same thing for charge 2. Charge 2 is a positive charge, so the electric field will point away. Charge 2 is really far away, so that one's going to have a smaller electric field, E2A. To find our total electric field at point A, we have to do the vector sum. EA equals E1A plus E2A. To calculate the electric fields, you have to find the magnitude using E equals KQ over R squared. R stands for the distance between your point and your charge. So for charge 1, this is R1. Put that on the diagram. R1A. For charge 2, this is R2, between the charge and the point. Let's get that on the diagram as well. Okay, so you can use all of this information to find the vectors for E1A and E2A. The directions of both of those are pretty straightforward. It's just to the right. Then you have to do your vector sum and write your answer. Okay, at point B, same idea, a tiny bit more complicated because we got some angles going on. So our electric field due to Q1 is going to point away from Q1. Let's draw that on our picture. So away is going to be straight down. So there's electric field due to charge 1 for at point B. Due to charge 2 is positive. So the electric field is going to point away. So it's going to go down and left. So there's our electric field due to charge 2. For our distances, the distance between charge 1 and point B is from there to there, R1B. Between charge 2 and point B is from here to here. Then we have to do the same deal. We've got to find the magnitudes of those vectors using KQ over R squared. Then we'll find our net electric field at point B, doing a vector sum. E1B plus E2B. Okay, so that's the idea. That'll give us our answer in a vector notation. If we want to find the magnitude, remember you got to use Pythagorean theorem there. So if you had a vector A that had x and y components, you would say that the magnitude of vector A is the square root of the x component squared plus the y component squared. And if your vector A looked something like that, and this was your angle theta, then theta would be the inverse tan of the y over the x. Okay, so you use that to get your polar notation. I'll put the answer up on the next slide, but hopefully you can work through it from here. For this homework question, we have two charged spheres and they're hung on strings with length L. Because they're charged and they have the same sign of the charge, they feel a repulsive force, so they're pushed apart. We're asked to find what is the separation between those charges. What we know is it says find the equilibrium separation. That kind of is what gets us started on this problem. So equilibrium means that the acceleration is equal to 0. If the acceleration is equal to 0, then the net force is equal to 0. So to start this problem, we're going to draw a free body diagram. So for our free body diagram, and let's just pick one of the charges to start. Let's do a free body on this one. There's going to be a tension in the string. That'll point along the string, of course. Force of gravity pulls down on the little ball. And there's going to be an electric force of repulsion between the two of them. Put in our coordinate system, X and Y. If you heard that jingle, that was my dog shaking with his Santa hat on. So we've got the tension up, we've got gravity down, the electric force is to the left. We'll of course have to break them into components and do the net force in components. Sum of the forces in the y direction is mass times acceleration in the y. If you write out that equation, you should see that it brings you to t cosine theta minus mg equals 0. Then in the x direction, we have the sum of the forces in the x is mass times acceleration in the x. This equation should give you that t sine theta minus fe equals 0. Here you'd have to remember to use that your electric force Fe is k times charge 1 times charge 2 divided by the distance between them squared. This is r. So you're going to put all of these things together, and remember you're trying to solve for your value r. So you're trying to find an expression, r equals something, and the only symbols you're allowed in your answer are Q and L and Coulomb's constant K. So those are the only symbols that should be in your finished answer. I'll give you one more hint as you get started. You may find yourself needing to use that if theta is small, then tan theta is about equal to sine theta. That might come in useful. So you work on through that. I'll post the answer, and of course you can get in touch with me if you get stuck.